accessing these particular methods, we would be using an object reference here. So we will be using the obj list, and so here we will be providing the respective data type. So now here, if we want, we have been this practice we have been known in the arrays itself, right? Means what the type of what is the type of elements we are going to store. So that particular type of elements will be mentioning it. So either it is an integer, or if it is a float, or if it is a bool. So whatever the things we wanted to store, so we'll be giving that particular data type. And here we will be having the new keyword, and then here we will be having the class means the class constructors we will be using it, and the class constructor data type also will be using it, and then we'll be closing it. So this is the basic syntax of the list implementation. So now whenever you wanted to use the implemented methods of the list, so we'll be using on this. So now here in this particular constructor, it might be comes with the array list, or it might be come with the linked list, and vector and stack anyways we will be not using it. So most probably we will be using on this particular array list. Now, first of all, we will try to understand what is this particular array list, and then we will be thinking about this particular linked list. So now here, the basic information about this particular array list is, so this is the next version of the arrays. Okay, so the first pointer is, this is the next version of arrays. So we have robo 1, robo 2, we have it, right? So means in the robo 2 there will be next advancements. So now, so that particular advancements we will be seeing it, right? So now that is where we will be having the advancement in this particular array list. So when we compare to the arrays, so this is the next version of the arrays. So now what is the basic differences between the array and the array list, and the memory allocations? These things we need to understand a bit more. We will come to that particular pointer later. So but now, what is the basic pointers of the array list, we will be trying to discuss over here. Now when you come to this particular array list, this is the next version of the arrays. Next one is, array list is a class. Simple. Now from where we'll be getting this particular array list? So array list is coming from iterable, collection, list. Here what it happened, so means collection has been implemented or extended?
Implemented.
Extended.
Extended, sir.
Collection extended in list.
It is an interface. This is an interface. This is an interface. How an interface can implement another interface? This. Now list has been extended collection, collection has been extended interface. Now here we have array list. So array list has been implemented because array list is a class. So this implements the complete hierarchy, the parent hierarchy. So what is parent hierarchy? List, collection, iterable. Okay, so these all methods has been implemented in the array list. So now that is what you will be writing it. Array list have implemented its parent hierarchy, which is list, collection, and iterable. Okay, so this is the basic set of information, and then you will be having a lot of methods here, right? So now here, whatever unimplemented methods we started to implement, that particular methods, plus it will have its own methods. So here you can say that array list will have inherited methods, and plus it will have its own methods also. Methods also. So this is how, so the basic array list is created. Now let's understand more about this particular array list. So here, actually here you can see the multiple nodes, but compared to this one, you can find much more information in this, and then it is easy. See, rather than having even though if it is in this one, so but still comparative means many a times when I have been compared these two things, I'll be seeing more information here, and you can't read and understand this all. So usually why I keep open this one is, you can see the list of methods. So what methods it is there, and those implementations you can see it in the Java docs. Okay, so this is Java docs. So that from the Java docs, you can see that what are the implemented interfaces, and then what are the known classes it can be used in. So those all informations you will be getting on it. And here also it is saying, so this belongs to the utils package. Now you can see it, right? So from the object, from the utils package, so you'll be getting this particular array list. So abstract collections, abstract list, don't need to go for those all, but still the first thing you need to understand that even this is also from the Java utils. So array list is also from Java utils. So we'll be writing that particular pointer also, so that it will be using it. So array list is from Java utils package. Now the next pointers. Now let's discuss these particular pointers. So what it defines for the array list. Now array list uses the dynamic storing. What do you mean by this? How it can be having a dynamic storage? What do you mean by dynamic storage? So now this, so now if you understand this one, so that is the basic difference between an array and array list. What do you meant by dynamic sizing?
It's continuous changing.
Its size is growable.
See, you are saying it. So now the name is, it is what that, right? Dynamic sizing, dynamic growing. You are not explaining me the logic. You are giving me the terms. So what do you meant by dynamic storing or dynamic sizing or whatever it might be? Dynamic storing, dynamic sizing. Explain the topic.
In runtime, sir, it will automatically grow its size according to the need. So,
How?
the,
See, that is what, see now you tell me, you are telling me dynamic sizing. At runtime, it will be dynamically changed. But how?
because it follows underlying the underlying data structure of growable array.
See, you
By
are not
using
giving
the
me
add method in the collection.
So it is a bookish knowledge. You
what
need to
add.
explain it better.
See, you are telling me add method will add that particular element. If you have really seen that the rest of tutorials or the previous sessions, you can easily answer this, which it means that you people didn't refer this previously, the previous sessions. And I am telling you, right, out of 100, 99 people will not answer this in interviews. One question to understand whether they have a, there are two major things: the array list and linked list differences across the CRUD operations, and then this sizing. So everyone will say this dynamic sizing or these things, but practically how it will happen? If you know this difference, then you can easily segregate. Oh, this is how it will be happen. And many of you people has been already written the notes on the array list. What is the default size of an array list?
10, sir.
10. Initial capacity 10.
See, now that would be called as an initial capacity or the default size. I'm just seeing that whether they have been given that information. I'm not able to see this here. Okay, any other tries on this particular dynamic sizing or growable or whatever the things?
If like when we want to add 11th element means it will increase the initial capacity. There is a formula like initial capacity equals to initial capacity into initial capacity by 2. It will all happen in the back end. Like it will be a dynamic thing, sir. With the initial capacity, there is a formula for this. We are explaining that in previous video.
See, what it will happen is, so when you have been derived, means when you have been defined. So now for an example, can I create in this way array list new array list of j. Can I do this? I'm asking, can I do this? Yes or no?
Yes, sir.
So we can do that.
I was really surprised why it was taking time for you to give me the answer for this. It's a simple object creation only, right?
Yes, sir.
This is a class and this is a constructor. I'm just creating an object reference for that particular class. I can do this, right? Now, when I have been creating this particular array list, what it will happen is, by default, it will have the size of 10 bytes. So now you will be having 1, 2, 3 allocations, 10 allocations it will be having it. Okay, dot 2, 10 allocations. Now, the concept of dynamic storing or dynamic allocation or global list, whatever the terminology, this is what the concept happens. Now, I stored here till 8th element. 8 elements I have been stored. So now how many elements I can store here? Overall 10. This is what the initial capacity or default capacity. It can be called default capacity or initial capacity. Whatever the name, the both are same. Now I stored 8 elements. Now what this will do is, internally it will have a formula called IC, means which is the initial capacity. Actually there are different formulas for this one. Basically what it will do is initial capacity equal to initial capacity greater than 1 or by 2, like this will be having it. Now what it will try to do is, so this is very important, you need to understand that. So the initial capacity by 2, if you've taken it, so it will be coming it as 5. Now what it will try to do is, immediately as it is reached to this particular number, so this is called as load factor. If the load factor is coming to the 80% of this, and so out of 10, if I loaded 8, means it is 80%, right? When it is reached to the 80%, what it will immediately do is, it will create another array. Okay. Now the capacity of this one is 15. Now what it will try to do is, it will copy the entire elements into this and it will give this one to GC. GC means
Garbage
garbage.
Garbage collector.
So now what it will try to do,
Garbage
all
collector.
8 elements will be coming to here. Still you have the space of 7. Now if it is coming near to 13 or 12, now what it will do, once again by default it will go and create this particular allocation for 22. So when you do this particular 22, now once again all these particular 12 elements will be copied into this and it will destroy this particular, destroy means it will send it to the GC. So this is how this particular concept of dynamic growing or dynamic arrays will be working. You got it? So the initial capacity of this one is, it can store 10. So now what it will try to do, so based upon this particular formula, so now I think it is changed in the newer version, but I don't know exactly, but you need to refer that one. So I was based upon this particular Java 8 I'm explaining. So probably in 7 they might be increasing this particular to half to some number or some certain formula changes might be there. But the concept, now here the concept is by 2. So now 10 by 2, 5. So 5 is added. So 15 by 2, 7 I added. So this is how it creates the new array on the fly. See, that is what dynamic, right? So runtime dynamically it creates this particular array, and then it shift all these things into this, and then it will delete this particular older reference and then give it to the garbage collector and refer to this particular array list. So this is what it will happen. So here what it was trying to do, transfer, change the reference to this new, delete the older one, or send it to the garbage collector where it will be deleted. So this is how this particular array list will be created. But whereas in the arrays, it will have a standard size. So now I'll be defining it. So it takes 5 minutes, it's only 5. In the middle, at the runtime, you can't dynamically grow the size of this particular array. So that is the basic difference between this array and array list. So now we got the logic, what is called as a dynamic. So you should understand. So this is the reason I'm saying it. When you have that particular theoretical knowledge, you will not understand. See, now here also you should understand the logic. So how this will dynamically grow? Why it is called dynamic array? So this is the concept behind the screen. It works. So first, increase that particular array by half, and then it will transfer. So now you can write the particular pointers also. This is very important. So first one, increase the new array based on the load factor. See, the load factor is very important. So based upon when it is reaching to the 8 itself, it will be increasing the new array with the formula, which is IC2, and it will be added to the exist old one. So 10 plus 5. So increasing the capacity with formula and create a new array and transfer the data, change the reference to new array, and delete or share this one to the GC, delete the old one. So this all things will happen within fraction of seconds in the backend. So that is the reason. So this is called as a dynamic storage or the dynamic array. Did you got this or any questions? So this is what it was saying, that dynamic array of for storing the elements. Okay. So now, anyways, so that is a point which you need to understand. It is dynamically storing this particular array elements. Now, let's see what are other pointers we'll be having. So now it is it's like array but no size limit. So that is what it was saying, right? So you will not have this size, fixed size. So when we will be using array and when we will be using array list? I given the answer and then I'm asking you the question.
Sir, for fixed size, we will use arrays.
That's it. So
if it is
I
variable,
know the
then
number of elements, this is the number of elements which I'll be having it. So if you have the fixed size, then I'll be using the array. But if you don't know the fixed, the number of elements which you need to store, at that point of time, you'll be choosing array list. So you should know, I'm telling you, right? So when you're going for a war, you should be taking that either it's a bow and arrow or with a sword. It depends upon the war, right? With whom you are doing. So that's how you need to choose whether it's an array or array list. On what factors we can take it? If I know this is fixed, so that it will be easy for me to go there. If I don't know it is fixed, then I'll be going with the array list. Okay, so then we can See, now these are the operations, right? So sorting, removing, adding the element, we can do any point of time in the middle of the execution or wherever you want, because we have directly methods for this particular array list. Even for array also we have the methods, but in array list I told you, right, this is the next version 2.0. so now you'll be having a lot of methods which it can perform this particular operations on this. Okay, now already we have been discussed about this is so now we seen it, right? So it have more advantages than array. So you can write these particular pointers also. So you can say that, hey, these have more advantages than the array from the traditional arrays. This is the next version, and then it also forms in the Java utils. We have been written this one, and it is like a vector in the C++. So this you can leave it. So because you need to understand the C++, then you can do the comparison. As of now, that pointer it is not required. The array list can be duplicate elements. It also implements the list, and all the methods of this one are maintained the internal insertion order. See, it is very simple. So we have been already discussed that arrays will, when the array has been implemented from the interface, then from the list interfaces, right? So that we have been already discussed. It is inherited from the lists. So which we have been already discussed this particular pointer. So now another important pointer is, as we discussed, my parent is allowing me duplicates. So obviously me also will be allowing the duplicates, right? So in the linked list and the array list, it will be allowed for duplicates. Yesterday we have been discussed this particular topic, right? So now in a particular array, so I can have 10, 10, 20, 20, 30, 40, 40, you have it, right? So duplicate of elements will be allowed as part of this particular arrays. So that is what it was trying to say, that it can allow the duplicate elements, and it implemented these particular list interfaces and all the methods it can be used on it. And the most important thing is you can have the order of insertion. So now whatever the order, so order of for the insertion, whenever you are inserting a particular element, it will store that particular order of insertion. These are the similar topics from the list, right? But this is child of list. See, obviously we will behave like our father or our parents. How our mother and father behaves, we also behave in the same pattern. So we will inherit that particular features, right? So these, whatever the topics which we have been discussed yesterday, almost those topics are applicable for the array list also. Now, what is the speciality? Means apart from the parents, what is your speciality is what we are trying to understand now. The basic things like duplicates and these all things will be there. Now, apart from that, what else we can bring it back for the array list is what we are going to discuss now. Now, same thing, the same pointers they are trying to say. So it can have the duplicate elements, it can have the insertion order. So now whatever the elements we have been inserted, so that particular insertion order, and Java, well, this particular array list class is non-synchronized. So yesterday we have been talked about synchronized and then non-synchronized, right? So so as part of non-sync, I hope I given this particular coffee example yesterday. So bringing that particular things. See now here, this is in non-sync concepts. We will be using this particular array list. Hey, I don't understand where exactly these non-sync concepts will come, and then how this would be accessed or synchronized and non-synchronized. So this is purely from the development angle we need to see on this one. So as of now, I told you, right, what is sync and what is async. So you understand that concept, and so this array list belongs to the non-sync. So just to understand that topic. I'm not asking you to by heart. So at least you know the basic implementation, because you need to implement and see this particular synchronized and non-synchronized, then only you will understand. But that is not relevant to, or from the testing point of view, it is not really required for us. And we will never do that. So that's the reason I'll not go into the details of this one. But yesterday, you remember, right, what is synchronization, threading concepts, and then we have discussed about sync and async. So now this particular asynchronization, this particular array lists are async. So you just remember that particular topic. Means it will not wait for that particular response. It will come and then proceed further with the other part of implementations. And when it comes, so that it will go and then it will serve for it. So when the access and the calls comes to it. So this is mostly implemented in the backend APIs implementation. We'll be doing it, but I don't want to confuse you now all those things. Okay, just you remember async. What is async? And then this particular array list is also an async. That's it. So the implementation parts, those things, don't go for that. So the next important thing is the random access on the index space. What do you mean by this? Random access. Someone has been written random access memory. What do you mean by random access memory? I don't know whether you have been copied this one or not, but still, yeah, you can, while preparing the notes, you can add these all pointers. What is random access?
Sir, in middle elements also we can able to access
Array list
through
implements a
index.
random access interface. So for that, we can retrieve data, retrieve any data like in the same time from array list. Like we are trying to retrieving like zeroth index data or 100th index data. The retrieval time will be the same for each one.
It's a good pointer. So
As
for
we as we follow the insertion order, we can retrieve with the numbers easily. That means we can access random.
so now every element have this particular. So now these are the elements 1 to 9. So now I'll be having 1, 2, 3, 4. These are the indexes which we have been given for this one, and it pursues or it preserves the insertion order. Now we'll be giving the indexes for this each and every element. Now what it matters here is, now when I wanted to access 3 or when I access wanted to 8, it is pretty simple to me. So now if I have 1000 records, accessing first record or 999th record, it is same. Because with just an index number, I'll pass it, and based upon this index number, I'll be accessing that particular respective element. It is pretty simple for me to do that. So this is called random access, means I can randomly access any particular element. It is not random access memory. That is your RAM, 8 GB RAM, 16 GB RAM. So those things will be there, right? So that is called random access memory. What it is, because in your notes, someone has been written that random access memory. That is where I'm saying this. It is that random access only, means randomly I can call any particular element with the help of indexes. That is what the point of here it is trying to say. Randomly it can access as it preserves the index. Okay. Now in array list, manipulation is a bit slower than the linked list. Anyone can explain this one?
So in linked list, we follow the doubly linked list method, sir. Whereas in array list, we follow like one address will be pointing to the another node, sir. But in linked list, we can have like insertion and deletion can be easy in linked list because of doubly linked list concept, sir.
Yes, sir. Because sir, I'm telling you, like when we like delete or update any data on array list, so it will like there will be a shift operation will happen, so it will take time. Suppose we
Where it will take
deleted
time. So will it be taking time in array list or linked list?
array in array list. Suppose we delete a element of its index. So after deleting it, it's need to shift all the after element. So that's why it will take.
See, so this is where I told you, right? So the most important topic which we'll be talking about is linked list with the array list on this particular crude operation. I think for the last session I have been given with the table. I just drawn the table in terms of I still remember, but it is very old, before 1.5 years, I think so. So for here we have been given insertion, deletion, manipulation, sorting, and all. So I have been given like array list and a linked list. So this is how we have been discussed last time. I think you need to refer that video. But before going to this particular comparison, so first of all, you need to understand what is this array list and linked list. Then you can go for this particular comparison. Then only it will make sense for you. Or else you may not understand. So because now you don't understand what is single linked list, double linked list, circular linked list. So comparison between that thing may not be possible now. So I don't think that can be understandable now. So first let's understand this. So this topic, the crude operations, deletion in these things, we will discuss that one in the later part of our session. Okay. So let's go on this next topic. So we can't create an array list with the primitive data types such as int, float, char. It requires to use the wrapper classes such as example. Okay. So first of all, what is the difference between an int and integer?
Integer is a wrapper class, int is a primitive data type, and integer refers int.
See, this is one of the important another interview questions. So what is the basic differences between uh, int versus integer? So you need to look. See, now there is, those are very simple and it is very easy to understand also. But where to use, what to use, you should understand on this one. I think this diagram usually I take it for the reference. Um, on this one. I have been stored all these things, but I have been missed it. So it is also in a colorful diagram. Okay, let me take you through this to understand on this. So this we all remember, right? So we have discussed about the primitive data types, non-primitive data types, integers, float, char, and then boolean. So integers will have byte, short, int, long. Float, in the floating point we have the float and then double. Char we have char. Boolean we have the boolean. And non-primitive data types are the classes, interfaces. We didn't discuss about the interfaces there. Classes, arrays, and strings. So these are the classes. So non-primitive data types which we have been discussed. So hope that we remember, right? Now, I missed that picture. So that picture gives you a very good information between these particular differences. What is this particular? Not only from integers, these things, even others also. It would be explaining for all of us. Okay, I'll look for this particular image and then I'll get it back to you. So what is the first important thing is, so here when you're passing it, so now many of the people might miss this particular point. So that's the reason I just wantedly pointing this one. So very important is we can't create an array list with the primitive types, means with an int, float. So this we can't create that. So we'll be creating any particular, for example, in the list of things, we'll be using it with integer. So now, what is the difference between the int and the integer? You need to understand. At the same point of time, for other declarations also, we'll be using on this. So I'll do one thing. So tomorrow I'll bring that particular note. So what is the difference between this and that? I'll check for that image. So where in that particular image you can have the complete differences of this wrapper classes, not only for the integers, for all other wrapper classes also you'll be getting it. So for the float and for the other things also we have it. So I'll try to see if I'm able to get that one. If it is there, I'll explain you on this. So now basically, as of now, what you can think about it is, so integer is like a wrapper class. Means yesterday we have been discussed, right? Wrapper class means core it is internal. On top of that one, we will create certain classes around this one to access them easily. So that is called a wrapper class. We discussed, I think, for the wrapper classes, we have been discussed about chocolates, right? So you can have I think I given that mango bites example. Mango bite toffee, having that particular wrapper, we remove the toffee means wrapper and eat the chocolate, right? So similarly, the dairy milk, you will have that golden foil previously, not now. So we'll have the golden foil. We remove that golden foil and eat it. So now that is called as a wrapper, right? The same way, the core is same. So the core is integer, and the storage of this one, everything is same. But on top of that one, we will build certain classes to access them easily wherever it is required. So those are the things which is called as a wrapper class. So integer is a wrapper class, so that we can take that particular wrapper classes and then we will be giving as part of this particular arrays. But in arrays, will we use the wrapper classes, or will be using the primitive data types, or this particular wrapper classes? In arrays.
Data type. Primitive data types.
So those, so now that is the reason. So if you understand this one, so immediately you can say the differences between these particular both. So however, oh, it's already 10:07. So okay. So however, what I'll try, we will do is, so we will continue the same session on this particular array list and differences between the array and then array list for tomorrow's session too. Okay, I thought like I can complete this array list and then start with the linked list also, but still we are here. Let's see what it may mean for us by tomorrow. So we will try to complete this particular array list on this, and arrays differences, and then we'll go for the linked list for tomorrow. Okay, that's it for the day. So we will